Welcome back to CAD/CAM tutorial. Today we are going to design a hydraulic pump in SolidWorks. We will design each and every part and we will see assembly at the end, and we will make animation of this motor. So let's see how to do in SolidWorks. It is very easy and beautiful design. Now here we will sketch the first part of hydraulic pump body. So let's see how to make. We will choose front plane, sketch, and here draw a horizontal and vertical center line first. Choose same, draw a vertical and horizontal, and it must be passed through origin point. Now select circle and draw circle. Just make the origin point above the origin point. Just mirror this circle. Okay, now define the distance from here to this point. 15.2319 mm. Okay, now select circle and draw a circle. Now let's define the dimension. Define this diameter 18.5 into 2, 37. Okay, and define this diameter 30 mm. Okay, now choose trim entity and trim inside circle. Okay, so this is the portion of inside hollow part in hydraulic block or hydraulic body. Okay, now select center point arc and draw a arc from here to here. Select both the end point symmetric. Now draw two circles. Exit. Select both the center point and make relation horizontal. Now select both the circles and make relation equal. Now define the diameter 10.2 mm and the distance 58 mm and distance from one end to one end 58 by 2. Okay, now it is in center. And the distance from here to bottom line 59 by 2 mm. That's it. Now define this radius 50 mm. Okay, now just segregate the thickness and everything. Now again choose line and start from here. Just go back this point and draw we want to draw one more circle. Better select 3-point arc. Exit. This one little drop. Up to here. Delete and try one more time. exit. Now select this center point and this center point, both make merge. Now this is the merge. Now you can drop or anything, it's up to you. First define this length, keep radius 11 mm. Now select, go to little bottom, taper and up to this point, exit. Now we will define some distance from here to this point, 84 by 2 mm. Okay. Now select corner radius, select 1.5 mm and select this end. Okay. And again choose radius, keep 5 mm and select this end. Okay. This is too big. Delete this. Or edit this radius, make 5 mm only. Now that's it. Now make relation this point and this point. Okay. Now it is defined. Now just try to mirror this length and mirror about this line. Okay. This concentric this relation, no need, delete it. Now it is already mirror, so it no need concentric relation or symmetric relation. Now select this all, mirror about this line. Okay. Now here it is mirror. So keep remember all the dimension. This is the main dimension of block. Select extruded boss here and here choose this face. Keep mid plane. Select 54 mm. Okay. Now that's it. Now select this face, sketch normal, and here first draw a vertical line. Here draw a circle and keep the diameter 23.82 82 by 85 by 2. .85 by 2, 5 into 2. That's it. And the distance from here to the center point 15.04 mm. Okay, just mirror this circle. For mirror we need a construction line. Select this circle and mirror about this center line. Okay, select line, connect from one end to this end. Now trim the inside unnecessary part. Now this is our body. Now select offset entity and choose here 3 mm. Select this face and make sure inside. Okay. Select extruded cut. Only 2 mm inside, not more than that. Okay. This is the sealing passage. Here we will fix the rubber seal for leakage. Now let's mirror this cutout. So choose front plane, mirror, and select the last cutout. See, it's going to mirror in opposite direction. Okay, it's mirrored here. Now we want to make some hole here. So select this face, normal, and choose hole wizard. And here select tab. We want to make some tabbed hole here. ISO straight pipe, and select here G1/2 blind, and this by default. Select the point. Select this center point. Select OK. Now the hole is created here. Now same, select this face, normal, hole wizard. Choose straight tab, ISO straight pipe tabbed, G1/2 blind 47.35. Keep 37.35. Select the position. So select this origin point. OK. Now that's it. The hole is created. This is the tabbed hole. How it will visible? Just go to option, documents, detailing, and select shaded cosmetic thread. OK. Now see, the tab is looking inside. OK. Now select this face, normal here, and here also we want to make some hole. And choose hole. Select ISO drill size, and we need 4 dia hole. Select position just above the origin point. Now define the distance 45 mm. 45 mm. Select OK. Select OK. Now these 2 holes created. Now we can mirror this hole. Just select front plane, mirror, and select this hole, 4 mm dia hole. See, it's going to mirror the opposite direction. Now it is mirror. Now here we want to make some name. We will first create a plane. Choose top plane, plane, and make little 60 mm. OK. Select this plane, sketch, normal. Select center line. Draw a center line up to here. Again choose center line. Select linear pattern. Select here this line. Keep 5 mm. reverse direction. We want 4 number of lines. Select OK. Now here 4 lines are created. Choose, first select this line and here write the model FX 305. Select OK. Now select this line and here write Bosch pump. Select OK. Maybe pump missing. Delete it. There is something missing. Select this line and write here Bosch pump. We will reduce the height, then it will comes full. Uncheck this document font and select this font 2 mm. See, it is visible. Even you can make 3 mm. Okay. Now select this line and here we will write something, some number 105. Okay. Select this line also and write some, and here we will write made in Germany. Just go to uncheck this document font and reduce the font size. Keep 1 mm. 1 mm is too small. Make it 2 mm. Okay, 2 mm is better. Select OK. Now select extruded cut. And here choose offset from surface. First select the surface. Small, and here choose reverse offset, so it will go penetrate inside. .5. Select OK. Now hide this plane. Now see, the name is penetrated in the body. So this is the our pump. It is ready. Now we will do one thing. Something mistake. I think this make 0.3. Now let's assign the material. We will apply chrome plate. Now see, this is the chrome plate. Now here the name is written Even you can make the black color to this name. See, now it is more visible. FX Bosch pump made in Germany. So let's save this body, hydraulic pump body. Save first. Go to desktop and create new folder, hydraulic pump, and save the first part, body. Now let's go for the next part. If here it will show some error, so you can do one thing, just cancel this all and redraw, so the error will go. Maybe some error due to the line, construction line. Now that's fine. Now save. Okay, let's move for the next part. Now here the next part is end plate of hydraulic pump. Choose front plane, sketch. The structure of body is same as the main body, so we will make the same thing, vertical and horizontal. Now here select first center point arc, exit, select both the end and make relation. Now draw two circles here. First make diameter 10.2, just mirror this diameter circle hole. Okay, now define the gap. 58 mm, and from bottom 59 by 2 mm, and this radius 50 mm. Okay, now make sure it should be above this origin point. Now here select 3-point arc. Okay, now select this arc center point and this center point, both coincide. Now define the radius 11 mm. Okay, now take it little down, select this point and this point horizontal, little down, corner and up to this line. Now let's define this gap 84 by 2 mm. Choose corner radius, select this corner 1.5 mm. Okay, now select 5 mm and select this end. Okay, okay, now we want to mirror this. Choose mirror, select this radius, this arc. Okay, this all things we will just mirror about this vertical line. Okay, now select this all part, we will mirror, or better select mirror, select this all part, mirror about this horizontal line. Okay, now see, this is our geometry. Now select extruded boss, select this face and extrude up to 12 mm. 12 mm. Okay, Now select this face, sketch normal. First draw a horizontal and vertical lines. Draw a circle. Keep the diameter 20.85 mm. 20.85 into 2 times the diameter, that's it. And the distance from here to this point 16.68 mm. Okay, just mirror this circle against this horizontal line and connect both the lines. Again choose a line and connect one end to this end. Exit and trim this. You can choose power trim and just drag and everything will be delete. That's it. Okay, now let's extrude it up to 2.5 mm. Okay, see, now select this face, sketch normal. First draw a horizontal center line. Select circle and draw a circle. Connect here to this line and up to here. Exit. Define the diameter 10 mm. Select trim entity and trim this. Select trim closet. Okay, and define the gap. It's up to you. 8 mm. Okay, now select mirror and select and okay, we need to define a vertical line first. Now choose mirror. Okay, now select extruded cut. We want to cut inside up to, keep the depth 2.5 mm. Okay, now that's it. Now again select the same face, sketch normal, select circle and draw 4 circles. Now define the diameter 16 mm. Okay, now select all the circles and make relation equal. Now all the circles are equal. Now select extruded cut and up to inside 2.5 mm depth. Not 2.5 mm is more, only 0.5 mm. Okay, now that's it. Now we will define some fillet. Select 1 mm and we will select first this edge. So now upper edge selected. Okay, again choose fillet. Select this inside edge and upper edge 1 mm. Okay, again fillet, select this inside edge and this edge 1 mm. Okay, and we will select one more time this side or directly select this face. Okay, Now we will define the material, select the whole body and go to steel and choose here iron and select cast iron. See, this is the cast iron. That's it. Now here select this face, sketch, normal. Draw some lines. Select this one first line and define something. Write some point. This is the code number. Drag this line little up and write something. Okay. Select one more line and select this line and write here CAD/CAM tutorial. We will just reduce the little 3.4. Still one word missing. Okay, now it's come. Okay, now select extruded cut and make the depth up to 0.3. Okay, and select this cutout color white. Now that's it. Now here we forget to add some hole. Just select this face, normal, and choose hole wizard. We want to add some hole here. Select the hole, ISO drill size and the size of hole 4 mm and keep the position just above the origin point. Make sure just above the origin point. Now define the distance. 45 mm. 45 mm. Select OK. OK. Now see, this is the hole for pin. That's it. Now our second part, the end plate of hydraulic cylinder or hydraulic pump is ready. So just save this part number 2. End plate. Okay, so let's move for the next part. Now here the next part is drive end plate. Last time we make end plate, now drive end plate. So choose front plane, sketch, and let's choose center rectangle. Okay. A rectangle with 90 by 120 mm. Okay. Now select fillet. Keep radius 9 mm and select the full rectangle. Okay. Okay. Now choose circle. Draw 4 circle at 4 corner. Okay, now define the diameter 9 mm. Okay, now select all 4 circles and make relation equal. Now all 9 mm. Just check the dimension between these two lines must be 36 by default. Okay, and the distance from bottom must be okay by default 51. Okay, now select extruded boss, keep 12.5 mm. Okay, now select this face, sketch normal. First draw a vertical line. Now draw a circle here just above the origin point, keep and keep that gap 15.5 mm and diameter 80 mm. Okay, and select extruded boss and extrude up to 7.2 mm. Okay, now select this face, sketch normal and draw a circle. Just find this center point and keep the diameter 20 mm. Okay, and extrude through all. Choose here through all. Okay, now that's it. Now go back, select this face, sketch normal, and here we will draw the our previous sketch. First draw a vertical and horizontal line, then choose center rectangle, again choose exit, select both the end point, define 50 mm radius, select circle, ten mm, distance from here to here 58 by 2 mm. 59 by 2 mm. Okay, just mirror this, no need mirror. Select this point and this point vertical. Now choose 3-point arc. Okay, now select this center point and this arc center point coincide. It must be okay. Now select this point and this point up to here and define this gap 84 by 2 mm. Okay, select fillet. First select this end. Okay, we will do one thing, delete this, we will go little down, make this little, then connect it. Now define radius 1.5 here and 5 mm here. Now we will try to mirror this. About this line. Okay. Now select both the circle and make construction geometry. Here we will add letter, mirror. Now select this all parts, opposite direction. Okay. Now this geometry ready, we will extrude it. Select this. We don't want any thickness here. And extrude up to 3 mm. Okay. Choose fillet. Select 1.5 and select this inside edge. Okay. Now select this face, normal, and here we will add some tab. Choose your whole wizard and select this straight tab, ISO bottoming M10, 24 by 20, blind keep 17. Select position, one here, just press escape. Now first define the distance, 58 mm, this distance 58 by 2 mm. $59 mm, 59 by 2 mm. Okay. Now make relation, select this point and this point, select this point and this point, vertical. One dimension missing, just go back. Again choose this point and this point, vertical. Now our geometry is perfect. Now select OK. Now see, select here detailing shaded cosmetic thread. Now you can see the thread inside, it is visible. Now select this face, sketch normal, and draw the circles in all corner. Keep the diameter 16 mm. Okay. Now select all 4 circles and make equal relation. Equal. Okay. And cut inside up to 0.5 mm depth. That's it. Now just go back and select this face, sketch normal, and here we want one more groove or one more circle. Draw a circle with 30 mm dia and cut up to 12 mm inside. Okay. Now choose right plane, sketch normal, select this 2D dimension, select corner rectangle and draw one rectangle in this line. We want to create a groove for circlip, 2 mm, 2.5 mm, and the distance from outer line keep 3 mm. Okay, now select a line, center line, and draw a center line from this midpoint, not origin point, make sure. Now select revolve cut. See, the grooves going to cut from the inside. Okay. So select this material and we will assign material iron, cast iron. This is the cast iron body. So this is the drive end plate of cast iron for hydraulic pump. You can define perspective image so it looks better. Here we will define some chamfer. Select this end. That's it. Save this part number 3. Drive end plate. Okay, so let's move for the next part. We forget to add some pinhole here, so select this face normal and choose hole wizard and select tapped hole, 4 mm dia drill size, 3 mm blind, and choose the position just above the origin point. Press escape key and define the distance, 45 mm, the same bottom 45 mm. Okay. Now this pin hole is defined. Now save it. Now we can move for the next part. Now here we will sketch the pin for hydraulic cylinder. So choose front plane, sketch, select circle and draw 2 mm dia circle. Keep the dia 2 mm. Okay, and extrude it up to 4 mm. That's it. Now define some chamfer, 0.3 mm and select both the end. Okay, and define the material. Choose chrome, brushed chrome, this pin, or you can select brushed steel. Now save this pin, part number 4, pin 2/4. Now here the next part is pin 4 by 6 mm. Choose front plane, sketch and draw a circle with the diameter of 4 mm. Okay, and extrude it up to 6 mm. Okay, and make the chamfer 0.5 mm and select both the end. And define the material, brush the steel. This is the pin. Now save this pin, part number 5, 4 by 6. Okay, so let's go for the next pin, next item. Now here we will make the seal for housing or body. Choose front plane, sketch. First draw a horizontal and vertical construction line. First draw a circle and keep the diameter 23.85 into 2. Okay, and keep the distance 15.04. Okay, select mirror entity and mirror this circle against this construction line. Okay, now select a line and connect from this end to this end. Select this line and mirror against this line. Okay, choose trim entity, select power trim and just that's it. Choose offset entity, keep 3 mm and select keep inside. Okay, now our geometry is created. Now let's extrude it up to 2.2 mm. That's it. Now define the color black, because seal always black in black color. We will not give full dark, or better assign some rubber material. Go to rubber. There are many rubber, matte rubber. Now save this part. Seal. Write better housing seal. Okay, so let's go for the next part. Now here we will sketch leg sleeve. So choose here front plane, sketch and draw 2 circles. Inside dia 20 mm and outer one 18.5 into 2, 37 mm. Okay, now select a line, draw a horizontal line with this point, make sure it is horizontal. Now define the length 21.68 mm. Okay, choose trim entity, trim this. Okay, and select extruded boss and keep 15.5 mm. Okay, now select this face, make it normal and here draw a hole. Select hole, ISO drill size and keep the diameter 2 mm. blind up to inside 2 mm, select position just above the origin point, press escape, go to sketch and define the dimension 7.75 mm. Okay, select OK. Now see, the hole is created. Now select this part and define the material satin finish aluminium. If you will go to aluminium, you will find here the material. This is the satin finish aluminium. Now save this part. Sleeve leg. Let's move for the next part. Now let's make the sleeve only. For sleeve leg, choose front plane, sketch, and here draw a circle and keep the diameter 18 mm. Okay, now choose offset entity, select the circle and keep only 1 mm outward direction. Okay, now select extruded boss and extrude up to 15.5 mm. Okay, and choose chamfer, keep 0.5 mm and select inside face. Okay, now we will define the material. Go to material section, metal, select brass. This is the brass sleeve. See, it will fix in sleeve leg. Save it. Part number 8, sleeve. Now let's make the assembly for sleeve and sleeve leg. Now here we will make the assembly for sleeve and sleeve leg. So choose assembly. Okay. And select our first part, sleeve leg. Now insert the next part, sleeve. Now select the inside face, mat, this face, concentric relation. Now select this face and this face, coincident. Okay, now this is the assembly for sleeve. Now save this assembly. Assembly leg sleeve. Let's go for the next part. Now let's make the oil seal. Choose front plane, sketch, select center line and draw a horizontal and a vertical center line. Okay, let's start. Go back to this point and draw a circle. Up to here. Now exit from the line and let's define this geometry. 7 mm, 1 mm, keep 1 mm. 2.25 mm, keep 5 mm. and select this distance. Okay, by default this one make 2.5 mm. That's it. And the distance from here to center point, keep 8.5 mm. Okay, select these 2 points and make a relation vertical. Okay, just drag it and make bigger. Select corners, all corners. Okay, now select revolve boss base. Choose this line as a axis. Now this is our oil seal. We will define the material rubber. Glossy rubber, but define color. We will define brown color. This color is better. This is the seal, oil seal. Now save this part, part number 10, oil seal. Now here we will make the drive shaft and gear assembly. So select new assembly. Okay. Cancel it. This portion. Define image quality higher. Okay. Now select here new part. Okay, we created new part. Now let's make the new part. Select front plane, select circle, draw a circle and keep the diameter 18 mm. Okay, and extrude it, and extrude up to 105 mm. See, now define the chamfer, keep 1 mm and select this face. Okay, now select top plane, sketch, choose normal, and here we will define some keyhole. So first select center line, exit. Now here choose straight slot. Defined a slot. Now let's define the dimension. 18 mm and radius keep 3 mm. And the distance from outer line make 6 mm. Okay. Now select extruded cut. First we will select offset. 6 mm offset from the mid plane. Select reverse direction. See, it's going to cut here. Select OK. Now see, the keyhole is cut. Now exit from the sketch and define the material chrome finish. Okay. Now we will attach some gear here. So go to design library. If you will go to design library, just go to ISO, standard, select power transmission, and here option gear. Inside the gear, one option is per gear. So select and drag it. Now here it is asking what dimension you exactly need. So module we need 2.75, number of teeth 11, pressure angle 20, face width 23 mm, and type you can keep 8, and shaft diameter select 18 mm because the shaft dia is 18. Select OK. It is asking one more, select no. Now here our gear, select this face, met, and this face. Make concentric relation, OK. Now select very important relation, this face and this face, and make the gap 67 mm the distance from one end. OK. Select OK. Now here see the gear is rotating. See, gear is rotating. Gear should be rotate with shaft. So we will add some relation. So open shaft, select the top plane of shaft, press Ctrl key and top plane of gear and make relation met. Now it is fixed. Coincident. OK. OK. Now both will work, rotate together, not separately. Now save this assembly. Now save this assembly as a hydraulic pump. Part number 11. Assembly drive gear. Drive shaft gear. Save. Select OK. Select OK. Now let's go for the another gear, drive gear, idle gear. Now here we will make the assembly of idle gear. So choose new assembly. OK. Cancel it. Now again the same exercise, we will increase the quality of image high. So it looks, edges look beautiful. Now first draw a shaft. So choose new part, select front plane, draw a circle with 18 mm dia. And extrude it up to 53 mm. OK. And here choose chamfer 1 mm and select this face, outer face. Now the shaft is ready. So just exit and select the, define the material, chrome finish. Refresh. Now we will browse the gear, go to design library, the same function what we did in previous. Select tool and here select ISO. In ISO standard choose power transmission, then gear and select spur gear. And here it is asking the dimension. So dimension is same as previous gear, 2.75 module, 11 number of teeth, the pressure angle 20 and the face width keep 23. Type A, 18 shaft diameter, select OK. We want only one, so select here no. Now select this inside face, met, this face. Okay. Now the next is very important relation. Select this face and this face and make distance 15 mm. Okay. Now it is in center position. Select OK. Now save this assembly. Save all. Go to our main file, hydraulic pump, and save this assembly 12. Idle gear. Save. Save yes. Now we need to add one more relation. See, it is rotating together. We want to rotate all together. Plane 2 and top plane, and make relation coincident. Okay. Okay. Now save it. Okay. Now we will sketch nipple for suction and reduction port. Choose front plane, sketch, and draw a circle with the diameter of 19 mm. And extrude it with mid plane up to 25 mm. Okay. Now again choose front plane, sketch, and here we will sketch some hexagon portion. Make sure this is horizontal. Now define the length 25 mm. Okay. And extrude it. Keep mid plane only 5 mm. Okay. Now make the hole. Keep the gap 1.5 mm. Okay. Now select extruded cut and choose here through all. Okay. Now that's it. Choose fillet. Keep 0.5 mm. Make 1 mm. Select both the end. Now select this face. First do one thing, make chamfer. Select this end and another end. Now select this face, sketch, select this circle and convert it. Now we want to create a path for helical. Keep 2 mm and reverse direction, and just check the last pitch, make it 4. Keep the angle 0 degree. 4.752 mm pitch. Okay. Now select the right plane, sketch, normal. And here we will sketch the thread pitch. We will start from this end. Connect this point to center of this. Select this line vertical. Now define the gap 1 mm. Keep the angle 60 degree. Now exit. Now select swift cut. Profile selected, just select the path. It's already calculated. Now select OK. Now see, the thread is created. Even if you want to edit thread, make this 90 degree. Exit, close. I think it's more, makes 70 degree. Okay. Now see, the thread is created. Now we will just mirror this thread. Choose front plane, mirror, select here swift cut. Okay. Now see, now select the whole body and assign the material. Go to aluminium and select sandblasted aluminium. This is our nipple. Now save it. Part number 13, nipple. Now we will start the assembly of hydraulic pump. Let's start the assembly of hydraulic pump. Choose new, assembly, OK. Now we will browse our first part, body or housing. Save plane. Now insert the another components. Now the next component we will bring assembly leg sleeve. Just press Ctrl and copy one more. No, we delete this. Bring one more time. Now insert a small pin, 2 by 4 mm small pin. Now here we will assign the relation met. Select this hole and this. OK. Select this inside face and this face. Select this face and this face, make distance 2 mm. Okay. Now rotate this component. Choose matte, select this face and this face. Okay. Now select this face and this face. Okay. Now select this pin and this hole, concentric. Okay. So this is finish. Now drag this geometry to the another direction. Now we will fix this geometry here. So select this face, matte, this inside face, concentric. Okay. Select this face and this face, coincident. Okay. So this one side sleeve is fixed. Now we will browse our next component, housing seal. Now select this corner, matte, this corner, coincident relation. Okay. Now it is perfectly fixed. Now try to fix this face, coincident. Okay. Now this is fixed, this seal is fixed. Now we will try another component. Now here we will apply idle gear. We will change the material for this gear. Okay. Now insert one more assembly drive shaft gear. Okay. This also we need to change this color. Make sure it's chrome steel. Okay. Now select this, shaft, matte, this hole, concentric relation. Okay. Select this face and this face. Okay. Now rotate the component, drag to the proper position. Now select this shaft, matte, and this hole, concentric relation. Okay. This face and this sleeve face. Okay. Now both the gear fix in their place. Just little adjust the gap. Okay, this also not fixed. Select this face and this face. Make relation coincident. Maybe something went wrong. We will do one thing, cancel. Maybe due to minor difficult. Now we will try to fix this. Select here lock. Lock with this face. Okay. Okay. Now it is fixed. Now let's try to rotate the gear. Now the gear is proper position. Now we will assign gear ratio, gear relation, choose mat, go to mechanical mat, select here gear. Select this shaft and this shaft. 18 by 18 reverse. Select OK. Now let's rotate. See. Now we will do one thing. We will edit this gear. Uncheck reverse. OK. Now try. Now this is perfect. See, the gear is rotating inside. This is the pressure port and this is the suction port. And this is the drive. Now let's continue our assembly. Insert the next part. Housing seal. Select this top face, edge, mat, this edge. Coincident, OK. Select outer edge and this edge. Coincident, OK. Now this seal is fixed. OK. Now insert the assembly leg bolt. The same component one more time. Select this component and press Ctrl key 2x4 pin. OK. Pin. Now first rotate this one component. Select mat. Select this face. OK. Select this face and this face. OK. This face and this face. Make distance 2 mm. Select this pin and this pin. OK. Select this face and this face. Coincident. Now this is the fixed. Now we will insert this body inside. Select this face and this face. OK. This face. OK. There is little deviation. Select this face, lock with this edge. OK. Now this is the locked here. Now sleeve is fixed. OK. First bring pin 4x6. Just press Ctrl key and make 4 pin. 2, 3, 4. Select mat, this hole. OK. Make the distance 3 mm. Select this face pin. Okay, here also make the distance 3 mm outer. Okay, now bring both the pins another direction, select this. Okay, this face and this face, 3 mm, and the last pin drag it here, concentric relation, and make the gap 3 mm. Now pins are fixed. Now we will browse our next part, end plate. First we will fix end plate. Okay, this is the end plate. Just rotate this end plate. It's like this. Now we will make the relation. Mat, select this hole, clear, and this hole, concentric relation. Okay, this hole and this hole, concentric relation. Select this face and this face. It is fixed concentric. Now see, back plate is fixed, end plate. Okay, now here we will fix some bolt. So do one thing, go to library, toolbox, select ISO, bolts and screw, and here choose hexagon socket head screw, and select socket head ISO 4762, browse, make the pitch M12 and height keep 80 mm with partial thread. Okay, and it is asking how many numbers, 1 2 4, we want 4 numbers, then cancel, select this. Okay, now select this face and this face. Okay, now this all bolt delete it, we will make we will apply a new method, copy mat method. Select here copy with mat, select this bolt, and here select the first hole, then face, delete this face, select this face and select this hole. Okay, now again try one more time, first select the hole and face, select OK, here also hole and face. Okay, okay, now the bolts are fixed. Let's browse the our next part, try nipple. Select this face, mat, and this hole, make it reverse. Okay, select this face and this face. Okay, so see here nipple also fixed. You can directly copy the nipple, just press Ctrl key, click the nipple and drag, and it's copy. Now you can drag it to another direction, mat, this hole, concentric relation, this face and this wall. Okay. Now here the nipples are fixed. This looking not bad, good. We will hide some thread. Okay. Now let's go for the another part. Drive end plate. Browse the sleeve, oil seal. Okay, just rotate this oil seal. Select mat, select this inside face and this face, concentric relation, select this face, and select this face. Okay, now it is fixed inside. You can see this is the main oil seal. Now these are the bolt. It should be fixed with this hole. Select this hole. Concentric relation. Or select this hole. Clear. Drag it this way. Concentric relation. Okay. Select this face and this face. Okay. Now see, our wall body is ready. So this is our hydraulic cylinder. It is totally ready. Just change transparency. Now you can see if you rotating this gear. First we will save this. We will save this assembly. Rebuild and save. Save as final assembly. Okay. Now let's make some animation and exploded view of this. Now here we will make the exploded view. So just right click, motion study, select motion. Before going for motion study, first do exploded view. Now first select the seal, take it out. Now select the body, end plate. Now select this bodies, all four body, and take it back. Now select this body, take it back. Select this washer. Now select this assembly out, this assembly also out. Now just rotate, select backside ring and select these pins. Select both the end body and select this body. Okay. Now collapse. Now just right click here and select collapse. Now again select explode, collapse. Now animation wizard. First we will rotate the model. One rotation, keep 6, finish. Now again choose explode. Start time 6 seconds and duration keep 11 seconds, finish. Then select collapse, next 11 seconds and this one keep 17, finish. Now rotate. It is calculating. Now change transparency, select motor, select this body, RPM keep 50, mm, play. See the motor is rotating inside. You can see it here. See. I hope you enjoyed this tutorial. Please subscribe our channel for more video and more projects. And thanks for watching.